Okay, so we are going to look at Chapter 3, Exercise and Problems number 4. And it reads, a velocity vector 40 degrees below the positive x-axis has a y component of negative 10 meters per second. What is the value of the x component? All right, so we are going to first have to make sure that we know what that vector looks like. So we will draw our Cartesian system. Here's the positive x side of that Cartesian system, and we'll put that vector 40 degrees below the positive x-axis. So here is our vector. This is 40 degrees. So we're saying there's our 40-degree mark. Now we're told that that vector has a y component of negative 10. So it should be pointing down, which it is. That's a good thing. And so it will extend down to negative 10 meters per second. So I can take that vector, I can pop it over here. This is that same negative 10 meters per second. So the question is, what is the x component? What is the magnitude of the vector that lies along the x-axis? And so there it is pictorially. Remember, we take our resultant vector, and that's generated by going head to tail with our two component vectors in this case. So that's the vector we're looking at. All right, if we think about it, remember our geometry, we have our idea of SOHCAHTOA, and I know my angle, so that's good, and I know my adjacent side, my opposite side. I want to know my adjacent side. So I want to know the A, the adjacent side. I know the opposite side, and I know the angle. It's the tangent function that's going to help me out. So let's remind ourselves what that is. The tangent of our angle is equal to the opposite over the adjacent. And in this example, that is our y component over our x component. Now remember, that is in this example based on the positive x-axis. So we want to always be attentive to that description. All right, so I am interested in that x component. We're going to label that A in our example. That'll be O. So the tangent of the angle, my angle is 40 degrees, but it's 40 degrees below the positive x-axis. So that's a negative 40 going in the counterclockwise direction, is equal to the y component we're given as negative 10 over what I'm interested, the adjacent. So doing our algebra, we'll bring A over to the other side. And then we divide both sides by the tangent. And that gives us our x component of 11.9 meters per second. So using the tangent function, we know our opposite value, we know our angle, we can find the adjacent. Now, like with any physics problem, this is not the only way that you have to do the problem. We could also have determined the hypotenuse using our sine function, and then using that hypotenuse to determine the adjacent using the cosine function in a two-step fashion. So if you did it that way, no problem. You should come up with the same answer, but the more efficient way in this particular example is to remember that tangent function. All right, good job.